data being transmitted. I guess the world just can't be without engineers. There will always be someone that has to fix something. You need people to ask the questions as to how things work, and if we wouldn't be asking these questions, I don't think we would be living in a society, in a civilized society.
Hello everyone, please move yourself as best as you can to the front side. We have water and brochures over there. Thank you so much.
I'm Maciej. I'm a software engineer. Two things that gives me a lot of energy is training sports, ultimate frisbee, and spending time with friends. I started with ICPC at high school. That's a good way to find friends. You share the same passion. Jan is my very good friend. We were in a team.
My name is Jan Tomaszewski. In 2019, me and Maciej won the CERC.
我是黄泽毅，2011年拿了亚洲赛的一个冠军。我是想说运气好。ICPC 的这个比赛其实对于我整个系统性的思维其实是起到一个重塑的作用。
I've been doing competitive programming for almost 10 years. ICPC helped me figure out my passion and helped me with career choices.
We learned a lot from ICPC, but someday the competition has got to end and we all need to transit to different things in life.
The most important thing I wanted from my job is to do something interesting.
And we were amazed about the multitude of things we can do here in Huawei. For example, our team works on algorithms and performance optimization. I wanted to have him in my team because he is a good programmer, good developer.
我是非常希望能够借助自己的算法编程，能够在行业里面去做出一番天地。如果你确实有一创新的想法，华为非常愿意支持这些新技术。
But at the workplace, it won't always be hunky-dory. There will always be problems that are difficult to tackle.
我印象中，围绕华为升腾芯片主打的一些算法，我们国内的团队其实已经苦恼了半个多月，做各式各样的一个调研，但是没有一个特别好的一个突破的一个方向。
大家有其他觉得这条路能走得通吗？能做实验吗？
But fortunately, there is always help around.
We were able to work with one another to tap on one another's strengths. There is one more person that really helps
Quick
us,
reminder again,
and this is our manager,
we have
Jan.
a translation interpretation service outside. If you need, please bring your ID and meet our service outside. Thank you so much.
We need to work on these tasks He is always able to
Hola,
understand
buenas
us.
tardes a todos los que deseen servicio de traducción español-inglés, inglés-español. Está disponible afuera, pueden tomar una diadema para su mayor comodidad. Están aquí saliendo a mano izquierda. You can pick an earphone to the translation service, English, Spanish, Spanish, English. Thank you.
透出了外面的光，让你一下看到了希望。
30% improvement and with some new algorithmic idea, and we plan on patenting it.
This actually proves that what you've done is really innovative, and it's not just some boring adaptation of someone else's work.
很少有公司像华为这么国际化的一个平台，让年轻的工程师能够接触到全世界各式各样的同行者，一起讨论、碰撞，去研究课题。这是一个非常难能可贵的一个机会。
Congratulations.
I went to Huawei. I can work on what I like to do and what I'm good at.
Bigger achievement.
I hope so.
Yeah.
In the future, I really want to be an expert in my field so that I can be successful in my career.
Maciek, please. Let's carry on.
Thank you very much.
Thank you very
much.
Okay.
Move it to the future. I want to work on areas I'm interested in, and when I can have an impact.
也希望能够更多的跟其他国度的工程师一起去做一些系统级别的创新，去做一些真正有社会意义的一些事情。
Hi, everyone. Thank you so much for being here. So, the world is full of diamonds and gems, and I'm so glad I have a lot here today. So, to make today's and this afternoon more informative and meaningful. Okay, so let's get started. So, thank you so much for being here. My name is Ning Tong, and I will be the host for today. First of all, it's my pleasure to call upon Mr. Carlos Mendoza. Please come. He's from Latin America Human Resource Department, Huawei. He's gonna deliver the introduction of Huawei. Together, go further.
Well, hello everyone. I'm very pleasure to be here with you in this magnificent event, this competition that brings all the wonderful students from Latin America. So I think we have a marvelous university supporting this. We have marvelous sponsors. And I think you can applaud yourself because you are the most talented people in the ICT. I am Carlos. Just a short story about myself. I joined Huawei in 2007 in the Caribbean area. I was born in Venezuela, and I work in the Caribbean with Panama and all the countries in Venezuela. I started as a PM, delivering a lot of solutions, and nowadays I'm part of HR multi-country in the Caribbean area, which is part of Latin America. So I'm very honored to be here with you. So let's get into business here. I'm going to show you a little bit about Huawei. Huawei is a leading provider of ICT infrastructure and smart devices. It makes a lot of emphasis on bringing digital to every person, home, and organization for a fully connected, intelligent world. How do we do this? We do it mainly by developing products with competitive, reliable and secure values and attributes that continuously creates value to our customers. In those products, we have different fields of communication, ICT. We have communications network, which maybe you're familiar with the IP networking, where we have routers, switches. We have the transmission family with a lot of multiplexers, our newest DWM technology. We have IT, where you can find our servers and storage. We have our devices. Maybe you're more familiar with devices because everyone has seen the phone. But in devices, we will see in the next pages a little bit more about our devices. And today, with an open collaboration and a big ecosystem, we have been able to touch some sectors that are not so used, are not so frequent by us. We're touching the automotive sector, okay, with some intelligent devices that help that enrich the sensation of the end users, okay? And we also are today supporting the energy sector with digital power, okay? So at the end, we have a lot of determination. We dedicate ourselves to enrich the life of normal people like us, and also to enrich the value of those organizations in all the sectors, okay? So Huawei was founded in 1987, and it's a private company totally owned by our employees. Nowadays, we are 207,000 approximated employees worldwide, of which 55% are working in R&D. One of our highest priority is to invest a lot in research and development, okay? And we do it through being sponsors of these types of programs like we are here today. We are in 170 countries, a little bit more, and several regions, okay? A high-level view of the world. We have our Asian region, we have European region, and we have our Central American and South American region, where we operate. Okay, we are number 5 in global R&D investment. That is something that we're very proud of. And today, we have over 140,000 active patents held globally. Okay, we hope to continue to be part of this development of new features and new innovation solutions worldwide. So let's get a little bit more down to earth about who we serve. Okay, we serve 3 principal customers. We have the consumers, okay, where we find different types of mainly solutions related to devices. We have our carriers, where we mainly develop, for example, mobile solutions, 4G, 3G. We have been there for a long time, and we have our enterprises. Through this wonderful cycle of information management, we have been able to start learning and have a predictable forecast of features that help us be a little bit more intelligent. So we normally, our information starts with distribution and interaction, okay? Then we do the transmission, processes, and storage, and in this processing, we start to learn, and we create more intelligence. So through the creation of intelligence, we have been able to have different kinds of products in different sectors. For example, in devices, we have our smartphones, we have our wearables. Okay, I'm not sure if any one of you have used the Huawei watch. You know, if you're running, it's a wonderful watch. We have smart home devices that helps connect all devices in the home, also to control lights and everything. We have telematics and all different types of scenarios for lifestyle services. For the automotive solution, we have brought devices that help for intelligent driving. Okay, mostly to see if you're out of the channels, things like that. A lot of sensors, intelligent vehicle control, intelligent vehicle cloud services, intelligent cockpits, and intelligent automatic optics. For connectivity, this is our broad business here. We have a lot of solutions in wireless, data communication, optical, and cloud. In computing, we have, of course, the storage, okay, in our different types of servers. And in cloud, we are now offering services for public and hybrid cloud. For digital power, we have our smart photovoltaic and energy storage systems and smart charging networks. Okay, this is fairly new, And we hope to continue to develop more solutions in that area that at the end will help contribute to the society because we're bringing more cleaner energy to everyone worldwide. Okay, just get to know a little bit about the numbers. These numbers are actually being calculated, and at the end of this month, we should be able to know we reached our target. Our target for 2023, was over 700 billion RMB, or CNY. Okay, we are pretty confident that it is going to be reached because our ICT infrastructure business has been very stable. Okay, we have stability there in the infrastructure, and for consumer business, we struggle a little bit, and we had to make some changes in our operating system. But today, proudly, we present the Harmony operation system that has been able to be working on more than 300 million devices at this moment. Okay, for Huawei Cloud, we are one of the preferred clouds for the industry, especially for finance and manufacturing. Okay, we're not the most powerful at this moment, but we continue growing up in our cloud business as we are growing the digital power and our automotive sector. For R&D investment, as I said before, which is top priority, the company has invested 20% of the revenue in 3 years consecutive, because we believe that this is the only way to contribute more and more. We are number 5 according to the European standard of investment of R&D. And as I said before, we have this 140,000 plus licenses by ourselves, and we are contributing a lot to an ecosystem with other brilliant partners that we have actually. Okay, our brand recognition, we have been recognized by our Boston Consulting Group as number 8 in the most innovative company. This is honorable because we are one of the few Chinese companies that has been able to get some recognition from this side. And for Universum, we are most attractive employers, mostly because we have a huge environment of multicultural people, members, with diversity and openness. Okay, we are within our core values. We focus a lot of openness to be able to create that synergy that we need to be in a multicultural environment. And for the best global brands, we also have been ranked number 92. Okay, also with a few Chinese companies there. Okay, what do we do for R&D? Mainly for R&D, we focus on creating a way to acknowledge more in the area of the mathematics and algorithms, chemistry and material science, psychics, engineering and technology. And of course, we focus a lot on creating development and pushing those development through the investment that we're doing day by day. Just to see a little bit more broad vision of how we operate worldwide, you can see here the presence, okay, starting from our technical support centers, okay, which are in the regions I just mentioned here. We concentrate a lot of our technical support centers here in the European and Asian area. We have our training centers, starting from this area here through the US to South America. And of course, this area is one of our principal areas in the world. R&D, okay, well, I think you guys here that are programming mainly focus on R&D. We have R&D in Canada, we have R&D in the United States, and then we have R&D concentrated here. We have Russia and some European countries over here, and of course, in China, we have a lot of R&D facilities. Okay, so how do we create value through the investment also? We have several channels that are very important to notice. We participate highly as partners and sponsors in the Institutional Electronic Electric and Electronic Engineering. We have the Association of Computer Machinery, and China Computer Federation. Okay, we also have an open channel that I invite you to, if you're curious and want to share some thinkings, which is called ChassPark. ChassPark is open for all public, and there we have a lot of debates with people about many things. So you can get there, high talent that is just waiting to hear from you, to see if some solutions are feasible, and to see how we can manage to create some next steps solutions. And for sure, we participate in contests like this one right now, the ICPC. We have the IMO for mathematics. We have the physics Olympics also, between others. Okay, we're going to see a little bit about that. So using these three channels to guide and open up and discuss with top minds, we have been able to have more than 262 industry challenges released. Okay, we have 1,277 academic papers published, and over 350 academic activities. And top algorithmic experts, we have already identified around 50,000. So we do think that these channels is the future. We want to continue helping through these channels to create and identify these top minds that are helpful for all the industry. Okay, as I was saying about the cultivation, as you see here, this is a little bit more open view of how many competition we support worldwide. Okay, here we have mathematics, physics, chemistry. Let me see here. Yeah, this is the chemistry, and we work in partnership with some other universities like this one that are open to create that talent cultivation. Okay, at the end, what we try always is to continue challenging ourselves as a company, as part of the society, to challenge basic science, application software, semiconductors, all the areas related to the ICT. So here, I think is a picture of yourself. It's not the first time that we have done this together with this ecosystem, and for sure we're going to keep on doing it. Okay, a big applause for you again, because this is really wonderful. This is really wonderful. Like other sponsors, we proudly have in our teams some people that come from these fresh seeds, okay, from these types of activities. We always know that it's a positive channel for motivation from your side and our side. We are always full of energy when we have these new incomers that come from these types of programs. Okay, let's just share a video.
Good morning. Welcome to China. You're at the ICPC Challenge Championship powered by Huawei.
We are facing huge challenges, just waiting to be solved by best of us.
The business of helping people prosper, for there to be enough and more than enough.
AI community.
I think I need to be very lucky for this.
But in general, I'm quite happy with the trip because it's very nice and very well organized.
I think I will get into the top 10 because I get the top 10 in the previous content.
Well, congratulations on taking on the challenge and doing such a wonderful job of solving the problems that have been presented to you and everyone on the globe because of the digital age that we live in. So thank you very, very much.
Thank you again. We continue to participate. This is just to highlight that it's always open. And at the end, we just want to continue to bring the technology into your houses. Thank you very much. It's been a great pleasure to introduce Huawei. And I see the glow in your eyes and wish you all the luck for your competition. Best of luck.
Thank you so much, Carlos. Thank you. Thank you so much for the very, very informative introduction. Hope you guys could have more idea of us. Okay, so next, let's invite our technical expert from Huawei Noah's Ark Laboratory, Mr. Amir Rasuli, which is Tech Talk, Autonomous Driving Progress and Challenge.
Working. Good afternoon, everyone. My name is Amir. I'm a senior staff engineer at Noah's Ark Huawei. As the topic of today's talk suggests, that I am an R&D professional that works in a very exciting field of autonomous driving. And my goal today is to give you some overview of what autonomous driving is, what's the origin of autonomous driving, and hopefully give you some idea of some of the open challenges, knowing that how eager many of you are to hopefully in the future enter this field. Okay, so in the past, let's say 6-7 years, that many companies started heavily investing in this field. You hear more and more about the advantages of basically autonomous driving, how you can enhance safety, and how you can make driving a more basically pleasurable experience. But the idea and the fascination with this goes far back. In fact, in mid-50s, giant companies such as GM heavily invested in portraying this picture of a utopian city that you don't need to drive your car and you enjoy the experience with your family. One of the things, as you can see here, of course, back then the idea of enjoying was smoking a cigar and drinking, but hopefully that is changing these days. So when we talk about autonomous driving, what do we really mean? So the definition of autonomous driving also has changed quite a bit in the past decade or so. And these days, they sort of categorize them into 6 basic groups. On one end, which is at the top, is basically level 0, when you are basically in the full control of your vehicle. There's no kind of assistive functionality. And on the other end is the desire state, which I call it, is a level 5, and that's when the car is capable of driving like a human. We are sort of in the middle, level 3, where basically the car is capable of handling the driving task, but in a limited context, and at the same time, sometimes it requests intervention because it realizes that it cannot basically handle it. But where all of it started, the history of autonomous driving almost goes as far back as the invention of the first cars. The first attempt at autonomy was basically remote controlling a vehicle. And this instance you can see here is autonomous cart or driveless cart, which was a project at basically McCook Air Force in Ohio. And they could successfully control the basically mobile cart from distance using radio signals. So closer to what we know today, we can basically attribute it to mid-50s, when the GM basically invented this automatically guided automobile, which was driving over a wire that was laid on the road, and based on the electric signals from the wire, it was able to control itself. The modern autonomous driving, as we know it today, should be attributed to work at Daimler. Eric Deckman at Daimler, they developed this car called Vamos in late 80s. And this is an instance of a full autonomous car that was able to use camera images only, process the scene, and handle all sorts of driving tasks. As we can see here, it was able to drive up to 100 kilometers per hour on highways. Later on in late 90s, the systems became more sophisticated. They were able to basically develop more reasoning, visual reasoning, and basically control the cars in more complex environment. One of the famous projects for back then was Argo. Perhaps one of the main basically milestones in autonomous driving can be attributed to two events hosted by DARPA. 2005, which was an autonomous race in deserts, and the cars, they had to fully autonomously basically go through the whole course of the competition and successfully finish. The sample you can see here, that's the car from Stanford called Stanley, which was able to finish, I think, about 3 hours something. And a subsequent one in 2007, which was basically challenge of urban driving. And as you can guess, it involved following traffic rules, handling interaction with other agents. And again, one of the cars that won that competition was from GM, the collaboration between GM and CMU. There were attempts at basically multiple vehicles running them autonomously, and there was this project with WheezLab in 2010, which basically a fleet of autonomous cars. They took the whole course from Panama to Shanghai. We also witnessed autonomous racing cars. This is an example 2012 by Audi, which was able to complete the very challenging Pike Peaks under 27 minutes, which is 12 miles of driving. That basically brings us to the modern autonomous vehicles that you all hear and see in the news, read about it in the internet. And there's a variety of these cars that you can see today. There are taxi services, there are passenger cars, there are delivery cars, trucks, and so on and so forth. So many of you know Huawei from their advanced technology in telecommunication, electrical devices, and so on. But Huawei is also one of the major producers of the technology for electrical vehicles and autonomous driving. And their technology has been widely adopted in a number of vehicles that are currently available in the market and in China. And I had the pleasure of driving one of these, well, sitting in one of these vehicles, and I can promise you that's one of the best one I've ever seen. Here are some of the examples of the vehicles that are available today in the market. Okay, so I gave you a little bit of introduction, talked about the origin of autonomous driving. Now I'd like to take a look at under the hood. So I want to show you what makes autonomous vehicles happen. You can roughly break down the components of an autonomous driving pipeline into 5 basically groups. At the very beginning, we have the sensory inputs, meaning that the car has to observe and collect data from the environment. And obviously, there are different ways of doing it. There are different types of sensors that these modern cars are using these days. We have radar, which is for long-range localization and perception. We have LiDAR, which is for mid-range localization and perception. We have camera images, of course, which is for detailed kind of understanding of the scenes. And we have ultrasounds, which is for a short range, very accurate kind of maneuvers, such as parking and so on. The next step in the pipeline is perception. As the name suggests, the task of perception is we want to recognize the objects and also localize them in the environment. And once we localize them, it's also important to sort of give them an identity, to be able to track across the sort of a time dimension to understand what these cars are doing. The next stage in the basically pipeline is prediction. So prediction receives the information from perception module, and the task of prediction is to make sense of the environment, basically interpret whatever the perception is observing. One of the main tasks here is the modeling the interaction between the agents, and consequently, we want to understand what those agents in the environment are going to do next. The output of prediction, the output of the prediction goes to the motion planning, and as the basically title suggests, the task of motion planning is to evaluate alternative plans, and depending on the objective of the vehicle and the safety concerns and physical constraints, produce a viable basically action for the car to follow. And of course, the output of the motion planning goes to some sort of a control and motor basically commands to basically generate the actions. For the purpose of this talk, because many of you are interested in computer science and AI, I want to focus on the 3 middle basic components and show you some of the subtasks and what are the challenges in each one. I start with the perception, and okay. So As mentioned earlier, the task of perception is about identifying the objects. So identification and localization can happen different ways. We can do it very coarsely, let's say fitting some sort of a 2D or 3-dimensional bounding boxes around the objects, depending on the type of sensor data we have, whether it is basically image or whether it is a point cloud collected by LiDAR. Or we can also do the localization basically at the pixel level or very sort of refined that gives you very accurate basically edges of the object. So you don't need to basically make any assumption about that. And lastly, as I mentioned, is the object tracking, which in a basically temporal dimension, we want to see how the behavior of a particular agent progresses. One of the major challenges in perception, like many other machine learning that you heard before, is generalizability. So in a traffic scene, the objects can appear very differently, depending on the lighting condition. Similar objects might have different properties, for example, different colors, there is a partial occlusion. So many factors are involved that makes the objects appear differently, and the algorithms have to be able to handle all of that. There are concerns about how the models are running on the sensors, different sensors. So you usually build your model using one sensor, and it is very important that model be able to basically use with a different kind of sensor because that's much more cost efficient. There's also the problem of out of distribution. So it doesn't matter how much data you collect, eventually to train your model, there's always some cases that you haven't observed before, and the models have to be able to handle these kind of scenarios. So there are a variety of solutions. I don't go into technicals too much, but just give you some idea of how they're tackling some of these problems. Of course, one of the straightforward ways is obviously scaling. Collect more data, you have more examples, your model eventually becomes more robust, but that can be quite expensive. Therefore, many basically companies relying on a very high fidelity kind of simulations. You can see an example here from NVIDIA. There are works on different methods of learning the features. So you don't want your model learn features that are very variable. You don't want to learn color to identify a car. You want to learn features such as wheels or the general shape of the vehicle to distinguish it from the different objects. And last but not least, there are certain fields of research about domain adaptations. Here you can see an example of, for example, data collected from different sensors, different density, basically LiDAR, how different they look, and there are methods that they make sure that the models are adjusted accordingly. Another problem here is the robustness. So your system has to be robust. It shouldn't be faulty. It has to be able to handle basically unexpected cases. One of the major issues, of course, is the noise, especially in LiDAR, because it's a laser base. You can get basically bad reflection collected by the sensor. You can get all sorts of noise, and you have to be able to handle it. There's one very interesting sort of field of basically research is also talking about adversarial attacks. So what adversarial attack is basically the intended way of manipulating the data that goes into the sensor to make the model make mistake. You can see here, for example, on the bottom right, that it can be obvious from the human perspective. You can see how adding a little bit of pattern on the stop sign can totally be recognized as something else. And sometimes it can be very implicit. You can simply add some white noise in a certain way that the object that from your perspective very accurately basically a stop sign, but from a model's perspective, it can be detected something else. Again, methods for this, we have this the denoising basically method to remove the noise from the sensor. We have vulnerability studies. There is a whole field of research on designing the attacks. And why do we want to design the attacks? Because we want to know what is basically making the models tick. So we want to understand those vulnerabilities. And of course, there's a whole field of research on designing defenses against these kind of attacks. Very interesting field of study, is highly basically popular, not only in autonomous driving, general computer vision, and many other machine learning fields. Sorry, this is a bit slow. So it brings me to my own favorite field of research, which is prediction. And in my opinion, this is the hardest problem in autonomous driving. So prediction can be done different ways. You can predict behavior at a very high level. You can predict actions. For example, for pedestrians, we want to predict whether they cross the street or not at a given time. Or in terms of vehicles, that can be whether the car goes straight or make a turn. It can be in terms of the goals and objective of the agents. That sort of reflects what the intention of that agent is, which also tells of what type of behavior we would expect. And lastly, the most common way of basically prediction is a trajectory. We basically want to predict the future states of the agents at every time step. But prediction is extremely difficult, as I mentioned. One of the main reasons is there are so many things involved in the environment that can potentially impact the behavior of the agents. Sorry, this goes a little bit fast. So here is, as you can see, an example on basically the factors that changes the behavior of pedestrians in the environment. There are a range of environmental factors and range of social factors. There are, for example, social norms that in different regions you go, people behave very differently. There is a time of day that can impact how people behave, how fast they cross, how long they've been waiting for crossing, and all of those factors basically impact the way people might act at a given time. There is also, in terms of diversity, so this got disconnected. Oh. This is... Sorry for the technical malfunction. So there's also a diversity problem. One of the things you can imagine, you are a pedestrian yourself, and you see often you engage in some form of communication with vehicles. Sometimes you wave hand, you want to ask for right of way. Sometimes you want to yield to the other agents or vehicles or cyclists, and you always use some sort of a hand signal. The problem here is that the type of hand signal you show can appear very differently. Depending on your personality, you might do a very subtle hand movement, or you might raise your hand and do something very more explicit. So from a perspective of the model, it has to basically recognize all of these differences and associate them to the same meaning if you want to really use it for some sort of a prediction. The representation also is very important. How do you encode the environment? How do you encode the context? And by context, I mean the other agents, basically the traffic rules, the road structure, all of that matters, because each one of these representations, they can provide different benefits. Many models work on the very raw, basically, LiDAR data. You just feed the LiDAR data, you try to categorize them and make sense of them. One of the most popular ways is vectorization of the basic environment. You basically project the observed or detected objects into a top-down view, and you vectorize it. So it captures the behavior or motion of the objects, as well as the classes, road boundaries, and everything. We have rasterization, which we use as some sort of a visual, like image-like representations. There are occupancy map. This is very basic. Basically, you want to know where is occupied, where is not. And we also have the egocentric images, which give you that sort of a rich kind of contextual information that you might need. So beside those key problems, if you want to do prediction, what it takes. As I mentioned earlier, interaction modeling is the core of the problem. Why it matters? Because we cannot just simply isolate a single agent and try to make sense of his behavior. We also have to understand the other agents around that particular agent because their behaviors are connected. So this is probably one of the most worked problem in this domain. And there are a variety of basically methods. In particular, causal reasoning, for example, is one of the very recent approaches that you want to know who's important in the scene and how the behavior causes other type of behaviors in the scene. Uncertainty is very important. As you can guess, you cannot 100% guess the future, especially most of the models usually predict 3 to 5 seconds. If you look at, for example, Waymo challenge, up to 8 seconds in the future you're predicting. So you can guess that it's impossible to 100% sure say, okay, the given car gonna be end up where. So to handle that, usually methods rely on some sort of a multimodal prediction. So based on the road structure and dynamic of the vehicle, as you can see on the right side, they generate possibilities, and usually they associate some sort of a confidence and a score to it, how probable each one of these possibilities are. And last but not least, this one is very similar to perception. We have an out-of-distribution problem, line tail problem, which is you basically don't have enough certain samples. And also the adversarial attacks is also a case in the prediction which we need to deal with. Okay, last but not least, motion planning is basically last stage in the whole AI stack. And as I mentioned earlier, you can see an example at the top. The whole task is about get the input from the prediction and try to basically produce probable kind of plans that you can execute, and based on the objective of the vehicle, eventually select one. Motion planning is probably one of those fields that is still heuristics, non-machine learning approaches are widely used. Why? Because usually you can have a very accurate estimation of what plan to execute based on the physical constraints, layout, and so on and so forth. And also is very robust. Machine learning approaches are also being used, but usually they're associated with some sort of heuristics because of their black box nature, because of some certain uncertainty in their behavior. Compared to other basic tasks that I introduced to you, the main challenge of motion planning is one, unexpected events. As I mentioned, it highly depends on the prediction. So if your prediction is not very good, or there are certain events that you simply cannot predict, these models have to be able to basically handle those kind of interruptions. Another very major issue for motion planning is evaluating it. You cannot just simply grab a car, run it on the street, and hoping that it doesn't hit anybody. It can be very risky. It can be very expensive. Therefore, you need to have some certain mechanism to basically evaluate it. That's why compared to the other fields that they rely a lot on naturalistic data, motion planning approaches are heavily developed and tested in simulation. Here you can see two examples of the simulators basically we developed in our own lab. So what is challenging about simulation is not really easy to do it. You need to have some sort of a realism. You need to get the physics right. You need to have basically accurate sensor models. You need to produce naturalistic behavior for the surrounding agents. Otherwise, it's useless. You cannot just put simple cars that are following a certain lane. It has to correspond to some sort of real-life behavior. Configurability is very important. We want to generate certain scenarios to develop certain aspects of the planner. We have out-of-distribution behavior. This is one of those very tricky things. So you'd want to train your model to avoid accidents. Collecting accident data or near-accident data is very difficult in real life. So we have to be able to produce that, at the same time make sure that it's naturalistic. And last but not least is the evaluation. Unlike other tasks like perception and prediction that we have in naturalistic data, we know what's the ground truth of the behavior that we observe. We don't have a ground truth for planning, especially if we are doing it in simulation. So generally evaluating, finding a proper metric to evaluate these kind of models is very challenging. So that brings my talk basically to conclusion. I want to just give you some view of what the future of autonomous driving is moving towards. You hear a lot about the connected vehicles. It's nothing new. It's been talked about for probably decades. But in recent years, with the introduction of 5G, 5.5, 6G, it's becoming more and more a reality. And there is a heavy investment in this connectivity between the vehicles, connectivity between the vehicles and the infrastructure, and so on and so forth. There is a whole concept of smart roads. You might find, if you search online, you might find some instances in Europe, especially, that are implemented. It is a very cool idea. You can basically incorporate this one. This image that you see on the top right is actually a real image that has been done in England. You basically can include sensors in the road, and the road is basically alarms the other agents that if the danger is imminent or so on, and you can basically act accordingly. There's a heavy basically study of drivers monitoring. I know this is not autonomous driving, but it is more and more is becoming a standard feature in the intelligence car these days. And last but not least is the explainable basically driving, especially with the sort of a rise of foundation models such as language models. The research is really going towards the way of not just producing a behavior, but also describing why you are producing this behavior, so it is more reliable and safer to use. That concludes my talk. I know we don't have any Q&A. After this is a break. If you feel like to come talk to me, more than welcome. I would be very happy to chat with you. Thank you very much.
Thank you so much, Amir. Thank you so much for the very informative presentation. I hope you all enjoy it. So, okay, our coffee break is almost ready, and we're going to have 15 minutes break. But before that, I want to give you two reminders. First of all is for a quick heads up for the session after the break when we come back. So we will have alumni sharing and the introduction of the challenge. We will explain understand the problem and everything, so please be back on time. And the second one is for in this room, we are not allowed food and other soft drink in the room, so please get your food and everything outside and finish it before you come back. And also, yeah, thank you so much for the cooperation. That's pretty much everything. Yeah, enjoy. So we'll start a break right now.
43动拐次下升线，广州。
My name is Rodrigo Rito. I'm a core network engineer. I work in Huawei in Brazil, São Paulo office.
Nem imaginam que lá no Canhambé hoje tem uma tecnologia atual, 5G.
Amazon, the people there still don't have so fast internet. So we need to deploy it as soon as possible to help customers. I work in Huawei since 2013, made a lot of projects, especially in 4G. This customer, Veloso, had a problem because their current core is not supporting anymore. They are looking for a vendor to support them. Tipo assim, a televisão que vocês usam tá tudo via satélite, né? Tá tudo pelas antenas ainda via satélite. O telefone também usa um pouco do Wi-Fi do satélite.
Eu sou Evandro de Carvalho Cordeiro, cacique daqui da aldeia Nova Esperança da Barreira da Missão de Baixo, do povo etnia do povo Cocama. A nossa aldeia aqui, ela é...
We could see, has a lot of children, has a lot of people. They don't have connection. The only way to go crossing the rivers and reach this kind of communities is by wireless. Filha, tudo bem? Ó, papai vai ter que viajar, tá bom? Não, é sério. My job is not so easy. I need to travel a lot. Tchau. It's a very hard decision, but my family understands, my family supports. The first phase to start a new core. I will need to be locally to do this. Let me explain to you. We from Huawei are together with Veloso team, okay? Okay. Your BSS system is integrated together with the Magma core, right? Yes. Yeah. First call means the first trying to access the network using a mobile phone with their SIM card, using your core and the wireless.
No, just only one call.
Just one call?
These are the internal calls. And you wait.
The system up. Okay. Paging is not being responsive by the terminal. I am connected, but I cannot find myself. The wireless.
Não.
My inspiration to become an engineer, especially in telecom. My purpose is to make all the people connected. I can be part of the evolution. Do estado só. Since I was there, physically, personally, I could see how valuable is our job.
Todo esto era tierra del jaguar. Pues a mí me encanta. Desde que era yo niño me gustaba saber que es parte nuestra. Es más, a veces causo risa lo que digo. Digo, el día que yo me muera me gustaría ser un jaguar. El ser humano es el principal depredador que existe. El ser humano no se concientiza, olvídense.
Por ejemplo, nosotros estábamos viendo hace rato, vimos las fotos del jaguar, que en verdad te deja con la cara así de ¡wow! ¿Cuáles son las amenazas para la biodiversidad y los jaguares? En la ignorancia de no saber cómo manejarlos.
Está la caza, está la franja ganadera, está la deforestación.
De todas las amenazas en esta zona, sí que ponen en jaque la resiliencia y la sostenibilidad del ambiente en el tiempo.
Aquí es la primera cámara del sistema que tenemos acá. Tiene 219 videos.
Instalamos cámaras, instalamos audiomos, se dejan sin que nadie entre para no perturbar la zona durante ese tiempo y los animales puedan pasar. 40 días después regresamos, sacamos tarjetas SD que están adentro de las cámaras que ya tendrán 3.000, 5.000 imágenes y videos. Las tarjetas SD de las cámaras también llegan a Mérida, se pasan a un disco duro, la UPI las recibe y se suben a la Huawei Cloud, donde ahí ellos las están procesando.
Hello guys, we're almost started. Please coming back. Thank you.
Estas cámaras trampa.
Hello
se
everyone.
activan con el movimiento. Y a veces el movimiento
Please
es
coming
una
back.
rama moviéndose con el viento. Tenemos teras y teras de información que si una máquina puede procesarla y decirnos qué está pasando, es mucho más fácil.
Necesitamos subirle una plataforma de Big Data porque es un volumen de información grande, procesarlo a alta velocidad y con inteligencia artificial entonces sí empezar a entender las imágenes y poder detectar los animales que nos interesan.
Estos son los caminos que usan los jaguares. Está allí. Entonces esta cámara registró todo lo que salió de aquí, de atrás, pegado allá, todo lo que sale de allá y todo lo que viene de esta zona del camino del cenote, más todo lo que cruza. Entonces debe tener algunos miles de fotos.
Lo primero que descubrimos es que era muy difícil convencer a alguien en invertir en la conservación. Conocer es algo sumamente valioso y medir, sacar información. Lo que hacemos ahora con monitoreo, por ejemplo, son cosas que Si no lo estamos viendo, no sabemos que está allá.
La gente no se entera que hay esos animales, no nos brindan la ayuda.
Hello, guys.
En la siguiente década,
We're gonna start right now. Please coming back soon.
estamos a tiempo.
Thank you.
El tiempo cada vez es más corto, pero aún estamos a tiempo.
Hey guys, please coming back soon. We're starting in 1 minute. Thank you.
Porque el día de mañana solo en los libros se va a ver.
Me gustaría que en 30, 50 años pueda seguir existiendo la selva que conocemos y que efectivamente tengamos estos santuarios en donde la vida sigue existiendo, sigue floreciendo, sigue evolucionando. Sigo siendo un poco optimista, ¿no? Pensando que sí se puede.
Please finish your food before I come in.
Todo esto era tierra del jaguar. Pues a mí me encanta. Desde que era yo niño me gustaba saber que es parte nuestra. Es más, hay veces causo risa lo que digo, el día que yo me muera me gustaría ser un jaguar. El ser humano es el principal depredador que existe. El ser humano no se concientiza, olvídense.
Por ejemplo, nosotros estábamos viendo hace rato, vimos las fotos del jaguar, que en verdad te deja con la cara así de ¡wow! ¿Cuáles son las amenazas para la biodiversidad y los jaguares? En la ignorancia de no saber cómo manejarlos.
Está la caza, está la franja ganadera, está la deforestación.
De todas las amenazas en esta zona, sí que ponen en jaque la resiliencia y la sostenibilidad del ambiente en el tiempo.
Starting soon.
Aquí es la primera cámara del sistema que tenemos acá. Tiene 219 videos.
Instalamos cámaras, instalamos audio mods, se dejan sin que nadie entre para no perturbar la zona durante ese tiempo y los animales puedan pasar. 40 días después regresamos, sacamos tarjetas SD que están adentro de las cámaras que ya tendrán 3.000, 5.000 imágenes y videos. Las tarjetas SD de las cámaras también llegan a Mérida, se pasan a un disco duro, la UPI las recibe y se suben a la Huawei Cloud, donde ahí ellos las están procesando. Estas cámaras trampa se activan con el movimiento y a veces el movimiento es una rama moviéndose con el viento. Tenemos teras y teras de información que si una máquina puede procesarla y decirnos qué está pasando, es mucho más fácil.
Necesitamos subirlo a una plataforma de Big Data porque es un volumen de información grande, procesarlo a alta velocidad y con inteligencia artificial.
Thank you so much for coming back. Please be seated soon. We are coming soon.
Poder detectar los animales que nos interesan.
Y estos son los caminos que usan los jaguares. Está allí, en esta zona. Entonces esta cámara registró todo lo que salió de aquí, de atrás, pegado allá, todo lo que sale de allá y todo lo que viene de esta zona del camino del cenote, más todo lo que cruza. Entonces debe tener algunos miles de fotos.
Shall we? Okay, welcome back, everyone. Let's get started. So here we are coming to the part of our alumni sharing with the topic of motivation outside of SAPC, my Huawei Research Center journey. So Mr. Juan Marquina and Mr. Nami Santo will share their experience with Huawei as SAPC alumni. I just please come to the stage first.
This one.
This one first and then back.
Okay.
Oh, you have to press the button.
Does it work now?
No. Yep. When I circle. Press.
Does it work now? Perfect. Hello, everyone. Hola. So, let's start. Oh. So, my name is Juan, and I'm very happy to be here, mainly because I love ICPC. I was a participant for 5 years, and my biggest achievement was to go to the World Finals in Bangladesh. I think that was the best event of my life. And also, I'm very happy to be here because right now I'm working as a software research intern in one of Huawei laboratories in the Dresden Research Center. And I really wanted to share my experience with everyone because I was in the same position as you guys. And I think this is a very interesting thing that's out there. So, perfect. Let's start theorizing a little bit about, let's start theorizing a little bit about the different computer science areas. There's some literature that has as many as 8 areas like networking, AI, applications, theory systems. But for this presentation, we're going to use a different type of categories. So I have 3 categories in mind. There's what you do at school, there's what you do at work, and that's also different to what you do in interviews. For example, in school, you learn about differential equations, you learn theory, you learn, mostly about that. And then you get into interviews, and those are different. You're implementing linked lists, you're talking about queues, about stacks, and then you get into the job, and you're never implementing a stack. You're and actually, this diagram, I like it a lot, but I think it can be made even better. I think that these areas don't really intersect. And this is a little bit funny and everything, but it got me thinking, where is ICPC in this diagram? Where would you put it? So I theorized a little bit with my friends, and we decided to put it right here, right there. You know, it's a little bit like interviews, but when you get to the harder problems, it stops being like interviews. And this got me a little bit worried because what I liked to do was ICPC. What I trained most of my university was for ICPC. And at some point, you have to transition from ICPC into further studies or into work. And I was really worried because I didn't seem to have a connection with what was outside of ICPC. So the answers to my troubles came in 2022 in the World Finals in Bangladesh because I had the opportunity to talk with someone that was working as a PhD student in the Huawei Dresden Research Center. For those who don't know, a PhD student in industry is someone who is just doing his PhD, but he's also working for the company. And when talking to him, he showed me that, well, first of all,
he was also an ICPC finalist from Brazil, and we had very similar backgrounds, and he encouraged me to apply to the different laboratories that Huawei had. He showed me that, hey, there's a laboratory in Germany, there's a laboratory in Canada, there are laboratories in China and different parts of the world, and you should really apply to those. And I was really worried of applying because the name of these positions were research internship. And, well, I didn't have any research experience because I was mainly working with ICPC. But he gave me a lot of confidence. I decided to apply to the concurrency group in the Resident Research Center. I read a little bit about the theory of operating systems, and I thought that I was ready for the interviews. And it worked. It was a good decision because right now I'm working in that laboratory doing some concurrency research. And the first thing that I had to do when I arrived to the laboratory was to read a lot. I caught up with the topic. I asked a lot of questions every day. For those who don't know what's concurrency, what are concurrent algorithms, well, they are not that different from the algorithms that you work already with queues, with stacks, but now we have an additional problem. That's how do we allow different threads to share the same space of memory? How can we solve this type of problems? And well, thanks to a lot of work, there are different set of primitives, there are different set of tools that the operating system already has that allows us to do this. And the topic is really cool. I really like it. And right now, I work mainly with the other members of the research center to implement ideas, to test those ideas, and also I work with different clients of the laboratory because the laboratory has tools, has libraries that other teams inside of Huawei consume, and I also help supporting that. And well, that leads me back to my diagram. Where do I put my current work? I put it right there, a little bit next to ICPC, a little bit next to what you expect from the actual work. I still have to work with different groups. I have to write clean, testable code. That's not something that you're expected to do in ICPC. But also, most of my work is very similar to my time training for ICPC. Because a lot of my work starts with an idea, a question that I don't know, and I start thinking. Like, what are the possible solutions? I read a lot, I ask to other people, and then hopefully I have an idea that looks that's gonna work. So I start writing it, I test it out, I use the different tools that we have inside the laboratory, and hopefully after a lot of iterations of doing this, I can say that the original question was solved. Here's where you clap. And thank you. And I want to finalize my part of talking with sharing my experience not only with the problems, but also outside of the work. Because for me, what was important in ICPC was not only the contest that I was participating in, but the people that I was meeting. I always loved going to training camps. Even though I was in pandemic, the moment I was allowed to go to training camps, I went to as many as I could. I also love meeting a lot of people in the regionals, and I love celebrating with my team whenever something good happened. I think the World Finals trip with my team was the best trip in my life, and when I went to Huawei, I just got more of that. I get to talk every day with people from ICPC that I have trouble with. I love talking with people that are experts in their area. They help me a lot. And I also love celebrating with my team whenever there's a breakthrough, and we go and just celebrate. And, well, I hope you like it. Right now, I'm going to pass the microphone. To my friend Naim, who's going to go a little bit deeper into the actual topics that we work in the laboratory. Thank you.
Hello. Okay, so I am Naim. I am 21 years old. I was 2 times world finalist, And yeah, and now I am coach for Unicamp. We have 2 teams here. And I am also working in the research center in Dresden with Juan, and I work in the formal methods team. Okay, so today I'm going to talk about a bit of concurrency and like why it's different and why it's interesting. Oh. This button is very confusing, so that's why. Okay, so the problem, for example, is you have a lot of dogs, because we all love dogs, and we want them to eat, but so you put a bowl for each dog, but the problem is things can get messy, and one starts to throw the bowl of the other, and then, yeah, just pure chaos. So how are we going to solve this? Okay, so suppose we have this code. So we have a function and a global variable that will have the bowl number for each dog to know where it should eat from. So we have this function, get bowl number, it will increment and return the value. So what we would expect is the first dog comes and then it asks, oh, what is my bowl? It gets, for example, 1, and the other gets 2, and they're both happy. Okay? But that's not exactly what happens, because when we compile the code to assembly, it actually breaks that operation into 4. So what actually we thought was one thing, it actually is 4. So we first have to load the memory, then increment, then store it. So what could happen is something like this. The first dog, it calls the function, it reads, the second comes here and it calls the function and reads from the same value. So before loading and storing the new bowl number, they both are reading from the previous. So what happened here is they will both get the bowl number 1. So we will have that thing that they are all eating from the same thing. And we don't want that, of course. Okay. So one solution is to use like this type of new integers, that's atomic integers. And it's one way of solving this problem. Okay. So this was the first topic of concurrency, which shows us that we normally think of operations as being atomic, and everything happens like, if it's one line, it should be just one thing, but actually it's not like that. Okay. Okay, the second thing is the compiler is tricky. For me, I thought this interesting because when we look deeper into the compiler, we can understand why C and C++ is so powerful. So the main power of it is the compiler. The compiler makes optimizations, like changing the order of some line of codes or stores or different things, and that can make the code much faster. But when we have different threads, it can get tricky. So, for example, we have this simple program. We have 2 threads. They both load. The first x equals 1, and then print y, and the second will load y equal 1, and then print x. So, for example, we can think about can this print 0 and 1? For example, y equals 0 and x equals 1. And the answer is yes, because this is not working. Wait. Okay. So yes, because we can have this kind of order. The first line comes, we set x equals 1, then the second line we print y is 0, okay. And then the third line, y equals 1, and the fourth, print x. So this is only one of the possibilities. When we have a lot of threads, they can happen in any order. Okay, so, and it's not deterministic, so it's very hard to predict what's going to happen. And this is one of the possibilities. Another way of thinking, instead of the trace, is this other type of mathematical model, which is thinking of it as a graph. So we can think of each instruction as a node, and we add edges from where it is reading from, and this will allow us to make a more powerful representation of the program. Okay, so for example, here we have that the print y is reading from y equals 1, so it prints 1, and the other is reading from the initialization. So, okay. Oh, so now the question is, can this print 0, 0? So both y and x is equal to 0. What do you think? No? So yeah, it seems that it cannot, right? Because if the first thread comes first, it will load x equals 1. And if the second comes first, y is equal to 1. Okay. But the problem is the compiler is tricky again. So we can't swap these lines. Okay? It seems like cheating, but this actually happens because this could be a good optimization if like the memory address of y is in cache or something like that. So, and now it's clear, we can print 0, 0. The first line comes, then the third, fourth, and then second. Okay, so, yeah. Okay, once again, if we put atomics, we kind of say it's not to optimize this, but using much atomics will make it slower, so is not necessarily the best solution here. But I just wanted to show that this can happen. And also another thing that I want to show is one of the tools that we have. So we have a tool that's called GenMC that we use to prove that some concurrent algorithms, they will never get to a search on failed. So for example, when we write a normal code, we can create a unit test, for example, and it is deterministic, right? If it will run, if it fails, okay. But when we have concurrent, some bugs, it can appear like very rare, like less than 1% of the time. So we need a more powerful model for that. So one of the ways is to use some of these tools that they represent every possible graph. So for each possible run, there is one graph, like this one. And we can use this tool to see if one of the possible graphs will lead to an error. So when running this, it will, for example, say that, okay, it explored 3 graphs and there was no errors. And yeah, so one of the things that we do there is libvsync, which is a library that's open source. We have a lot of reliable algorithms. So all of them were like kind of unit tested with this GenMC tool. And yeah, that was it. I hope you learned something new and enjoyed.
Thank you so much, Nam. Thank you for both of sharings. Okay, now we are coming to the very significant of the introduction. So next, coming to our next very important section of the challenge. So the introduction of the Tech Arena 2024 LAC Challenge. Please allow me to introduce the technical expert from Universal CAP, Mr. Jingbang Chen. He is also the president of Universal CAP. He will introduce the Huawei Technical Arena 2024 LAC Challenge.
Hello. So before going to the challenge problem, I will also use the time to give a brief introduction of the Universal Cup. And I think some of the people already know, some of you might not know, but no worry, I will just quickly go through what this actually is. So my name is Jingbang Chen. You can call me Jingbang or whatever. And actually, I am still a contestant because the World Finals hasn't happened yet. So I have to compete in Lutzer next month. Yeah. So I am basically the same as you guys. Although I'm quite old, but I'm still a contestant. Okay. So Universal Cup, so we are an official organization, although I don't know what does unofficial mean here. So we are dedicated to offer training resources
as well as all kind of competitive programming-related outreach activities to the whole community. So we started this project from last year, January. In the first season, from January to July or August, there are over 750 teams that registered and competed in the Universal Cup Training Contest Series. And for this season, we have more than 3,000 teams registered. Well, the majority of them is for preparing for the ICPC contest, and some of them are maybe just in high school, and there are also some of them are already retired or maybe already employed, and they really into the programming competition. But anyway, so there are 3,000 teams registered in this season. And our contest, I will show you later, the resources is coming from Asia, Europe, and America. And last season, we have 22 stages. And this season, we already scheduled 28 stages, and there are more yet to come. And also, Universal Cup, we are also happy to help with technical support for any kind of the CP-related events, just like that's why I'm here. So we have a cooperation with Huawei, and today the Huawei Challenge is run through the platform from the Universal Cup, and I'm also the on-site judge today. And the other president who didn't make it to here, he will be remotely online helping us. And maybe next time, maybe next year, you guys will have the chance to see him. And he's also will go into the World Finals, and if you guys get advanced, you also see him there. Okay. And this is the official website, so if you want to see more information, you can just go into the website and check on our information and introduction. So the training contest series is like, so every weekend, or almost every weekend during the season, we are hosting a contest that's fully ICPC style, like 5 hours, 3-person team, and frozen ball, all kinds of rules are the same as ICPC format. And we hope to have such kind of weekly contest that actually helps the teams or individual to boost your ability in the competitive programming. Because we are aiming at helping the teams from all over the world, so there's a time zone issue. So that's our plan right now, is we set up flexible time windows. Like there are many time windows over here, but basically any team from anywhere in the world, they would got a comfortable time window on the Saturday. And the reason we choose Saturday is that there are more events, or maybe originally there are some events. They usually will happen on Sunday, so we don't want any conflict with them. So we basically hope the team that can take part in our training contest series on Saturday. And there will be discussion, there will be editorial coming after. And we have a Discord server that has already like 1,000-ish people that are on it, and with all kinds of people that actually can discuss, communicate about the problems, and also discuss about the contest. This is the contest from the first season. Season 1, that is from January 28th to July 15th. So these are the resources that we have. Like there are some official ICPC regional contests, and there's also some local contests from Japan, from Poland, or maybe from India, and maybe from some random places in China. And we are very grateful that we actually, for every contest here, we asked the permission from the officials, and also asked permission from the province sector, and all of them is very happy to help with us. And in the current season, they actually continue supporting us by providing their contests freely and providing these resources, valuable resources, to all people who is interested in practicing and training. I made a little bit summarize here on the almost 50 contests so far. Could you help me? Yeah. So this is a simple summarize on the currently 50 contests right now from the stage season 1 and season 2. So we have a majority contest coming from the China everywhere. And basically all our staff are the coaches, famous contestants, and most importantly, we are the problem setters of the officials contest in China. That's why we get hands on these resources, and we are happy to offer them to anyone free, without paying anything. And we also have contests from Japan, from India, from South Korea, and United States, which is the NAC, and Russia, Ukraine, Poland. And Polish people actually help us a lot. They actually provide us with 5 contests, but we haven't scheduled them yet. And these are so we have our friends and also have a partner from all over the world that is actually happy to help with our projects. And I think this actually proves that our CP community is actually quite united. I think this is a good phenomenon. Okay. I don't think this actually works. Excuse me, please shift to the next stage. Okay, so scoreboard. So we had, this is one of the stage, and I actually practiced on this stage last week, and we can see that it's basically the same as the ICPC format, and we have 13 problems, and we have all teams from Japan, China, US, and Russia, and maybe the other European, and also we also have a lot of teams actually practicing on Universal Cup from Mexico, Argentina, and Brazil, and I actually talked to some of the people like earlier today, and I'm quite happy about that. Okay, next page. Let me introduce, so we have a season. So the season means that we have an overall rating to value your performance throughout all the stages. And these are the top 10 in the current season. And these are the players and are the participants actually in these top 10 teams. So besides these LGM people that you might already seen them on Total Forces, and there we actually have a lot of people who was a strong contestant in ICPC and more. Maybe currently they are training and practicing for the upcoming World Finals. Like tourists, like we have Ming Yang Deng, the rewinding guy. Like they are the champion of ICPC World Finals in 2013, 15, and 2021. And you know Radovish, you know Umnik, you know Khan. And we have the strongest team maybe from the NERC region in the upcoming World Finals, the HSE team. And we also have maybe the strongest team in China for the upcoming 3 World Finals. They are also ranking in the 9, 10 here. And we also have the team from Harbor Space. And what's not mentioned in here is like the Oz Devon Wong guy. And also in the rank 6, there's a guy named as Ji Yushen. They are high school students, but they will represent China to participate in the upcoming IOI in Egypt. So basically, Universal Cup aims at the people that of all age. You might be just high school students, you might be college students, you might be just like 30, 40 years old. As long as you are still passionate about the competitive programming, feel free to join us and join this great community. Next page. So starting from last year, January, this is actually the registered team that actually try to join the Universal Cup community. So starting from 300-ish, and to right now, we already have 3,000. And because we upgrade our platform and upgrade our technical support, so starting from season 2, we actually have a dramatic increasement of the teams, and we expect maybe next season we'll have more, and we hope to have people from all over the world that actually participate in Universal Cup. So the teams are actually from all over the world. So we actually do a summary yesterday, like we just grouped the teams by their country or regions. So we can see that the majority of Asia and Europe and North America, and also we have like from Australia, we also from Latin America. I think that we are starting to have a more and more global impact on worldwidely, and we hope to have more people to participate in us. In the future, we have some idea that is planning to do or maybe yet to come. Like we want to provide more training opportunities to help you guys prepare for official competitions like ICPC, or maybe just for fun. It's actually up to you. And we also want to provide resources in other form, including seminars, lectures, or maybe just some problem sharing, some brainstorm events. I think this kind of event will actually be very helpful to our community. And we also want to provide contests not just in ICPC formats. We already run some extra stages. Maybe you have heard about the Prime contest for individual. And right now we are cooperating with Huawei, so we might have more and more challenges that actually related to the industry, related to the real world, that are yet to come. And we also hope in one day that we can have our own on-site final, a great party for the CP people, that's for the all age, that everyone who is passionate here can actually come together, we can discuss in person, we can compete in person. I think this is quite exciting. This is my personal email, and because I have participated in, I started to code my Hello World from 2010, that's like 14 years from now. And after high school, I participated in ICPC. I got the regional champion in my first ever ICPC regional back in 2017. And unfortunately, even I'm already too old, but right now I'm still an active student contestant that I'm going to my final world finals. Well, so I think I can say that I love this very much. So, and I'm also the coach of some school, and feel free to talk to me later, or maybe just send email to me, or maybe just join our community, just chat in the Discord. Feel free to share with me your idea or maybe your advice of our Universal Cup. We hope to see more and more people from Latin America that can actually join our community, participate in Universal Cup. And thank you very much. And that's all for today's quite brief introduction of the Universal Cup. Thank you. Okay, so right now we go to the challenge part, okay? So, I mean, the time is a bit limited because everybody is so happy about the tea time break. And yeah, so the contest will start shortly, and the duration time is 3 hours. And unfortunately, you cannot participate in teams, which you already know about it. And this is the website, the platform you're using will be the Universal Cup website. And we have already sent your passport and login account to your email. If you didn't get it, that means that you maybe just mistype your email. But don't worry, we already print out a paper copy and put it on it, and later we give it to all of you. And I'm the on-site support, and also with Joni Yang, and also Qin Yushi here is also from Universal Cup, the other president. He will be remotely helping online, and also Yong Wang and Li Mingzheng. So we have prizes, which is quite promising. So the champion we got a 50,000 Mexico currency, and the first prize there are 4 people. They would got a Huawei laptop, which I really wanted one because I just broke mine. And the second prize, 6 to 10, we got a watch, and the third prize, 11 to 20, we got headphones. And also, we also have a special prize for the coaches. And so that's why I think we already have some coach register and prepare for the coach award. The challenge rooms here is like, I mean, it's quite long, but I still have to go through it, so let's be patient. So you are allowed to use C, C++, Java, Python, Pascal, D, and Rust. Yes, always has a Rust. And this is quite important. Your score depends on your last non-zero score summation. So make sure you don't submit anything wrong in the last 3 or 4 minutes, or otherwise you might get a much lower unexpected score. And we will check the code whether no duplicate code is allowed, and it will be invalid. And you can use the local materials like the paper documents, that your code library, and maybe some electronic document. But please just be nice, okay? And the network is only used to. Sorry, I didn't finish it. And the network is only used to load in the competition page. And please don't discuss online with other people. And because I am here, so I will just, actually, I will passing by secretly behind you and check whether you are doing something correctly or not. So pay attention. If you need clarification, there are two ways. And the most recommendation way is like, there is a clarification panels on the website. Just find it and just submit your question on it. We will make sure that your every reasonable question will be answered. If no, just raise your hand. I will go to your place and try to see what's going on. And don't worry, I will be around for the whole 3 hours. Okay, now come to the even longer statement that I think they might expect me to read all these things and I will be dying on the stage, but which I will not do this. But this is a quite famous classic question, problems in the reality. It's called a cycle basis of a graph. Because it's like there's a graph and you want to represent all its cycle, you only want to represent them by a small amount of basis elements that all the rest, like the circuits, can be represented by a linear combination of the cycles that you've chosen. So this is a quite classic problems. And they actually related to many other areas, including like physics, maybe electromagnetic principle, and all kinds of these geometry, all kinds of things. It's quite interesting. So today, what we ask you to do is like, we are giving you an connected undirected graph, and you are supposed to find us an arbitrary cycle basis. But what's our objective goal? Our goal is that you have to make sure the cycle basis you found is as the sum of the lengths of all this cycle is as short as possible. So that will be the challenge today, to find the minimum length cycle basis. I think I might need to explain more on what a cycle basis is, maybe in a more mathematical way. So basically, it's like you have to find a set of some cycles. First, any other cycles or any other subgraph that every vertex has even degree, they can be represented by a linear combination of the cycle basis that you choose. So there's a hidden condition is that no more cycle can be added into your cycle basis, because whenever you add something, it might already be represented by the rest of them, which already violates our condition. So this is called a cycle basis. I'm pretty sure you have already learned something for the exclusive OR spaces, like some classic problems. Is this the concept of the basis is the same. It's only the difference is like this time we put it in the space of all the cycles or all the subgraph of even degrees. If you don't understand, maybe just think about this, and we have an example in the next page. So on the left, this is an undirected graph, and we can see there are 4 cycles or loops, like from V1, V3, V5, V2 is one of them, and V3, 7, 5 is the other, and there are 3 and 4. So we can choose all these 4, and they are actually linear independent, and we can call that these 4 of them, they construct a cycle basis. I'm not saying this is the optimal, but this is a cycle basis. What if we add a cycle of 1, 3, 7, 5, 2? This is actually violate the condition, because it can be represented by the cycle 1 and cycle 2. So this is not allowed. So this is our problem. This is the input. So we are giving you the edges, and your output should be outputting the cycles in a way that's linked by the hyphen. And the scoring method is like this. This is really the part that you need to pay attention to. So there are 30 test cases in total, and we will determine whether the cycles that you output is independent. If not, you will get a 0. And for every test case, the submitted algorithm is scored as follows. The score will be base times max 1 subtract length minus refer minus reference. So that means that the closer you get to the optimal distance, the higher score you got. And yeah, obviously. Yes, next page. So I think there's something that's missing here. Maybe just give me maybe 1 minute to explain. So you can imagine that the checker is very hard to write because you actually have to run a Gaussian elimination to check whether your cycle base is valid or not. So we are running a pre-test system here. So you will be given so we will only return the first 10 test cases of less than maybe around 10,000 LGs that during the contest you'll be only given the result of those 10 test cases. And there will be a system test cases and the result will be published later. So please pay more attention to the time complexity or maybe efficiency of your code. And yeah, and the result of during the competition might not fully reflect your algorithms in the system test. I'm pretty sure you have done total forces, so it's the same. And the other thing is that this is although this is not the official LAC, but this is quite of a serious competition. So I don't, as the chief judge, as the on-site judge, I don't want to see anything that actually violates the spirit of the fair competitions. For example, if I find that everyone is actually discussing with people online, you will be disqualified. If I find anyone that is submitting randomly and submitting a lot, trying to block the queue of the judging, you will be disqualified. I'm pretty sure that everyone come to here, we actually want to enjoy our time here. So I hope we can together make a wonderful, excellent challenge competition. And wish all of you good luck in the challenge, and wish all of you good luck in the upcoming competition. I am a big fan of the Hunger Games, so I will use the sayings from the Hunger Games as the ending. So may the odds be ever in your favor. Thank you.
Hold on one second. Thank you so much, Jinbang. Okay, so can go back. Okay, thank you so much, guys. We're almost there. So since we're a little bit running late, so our game is postponed in 20 minutes. So we'll start it in 17:50. Now it's coming to the end. Thank you so much for being here. Hope you guys enjoyed the talk and everything, especially for the food. And also, okay, so for the other contestants, please take your belongings with you and follow the stickers and the banners to the direction. And Gabby.
Wait. Everybody sit down, please. We have a surprise for you. There is somebody who wants to say hello. So please welcome Mr. Bill Poucher.
Okay, let's see. All right, this works. Hi. Well, thank you very much. I'm delighted to be here from northern Mexico. We call it Texas, but I've just given up on borders, you see, because I believe in people. And you guys are just really spectacular, and I love to see the energy involved, and I love to see you making choices that help life flourish. It's just that simple. And thanks to Huawei for putting on the challenge and being a great sponsor. And I actually looked up there and I thought, holy cow, when I was in graduate school, we were studying similar problems, because these are the kinds of problems that will last lifetimes in terms of the benefits they provide if we can figure out how to solve them. So I do know that one of the great moments in any meeting is when the speaker says, well, that's about it, so why don't we go have some fun, and I'll see you at other events. But there is one thing, the Iteso family putting on the Latin America Challenge, the Latin America Championship is an extraordinary event, and I want to thank everyone who's made this possible, and so thank you. Bye-bye.
Thank you very much. Now you can go to the challenge. Good luck for all of you.